So I'll just had a chat with Victor. We last time I saw Victor was, I think, 10 years ago in another event. I've used Suricata in the past, and you're almost working for 20 years now on the project, an open source project. I think it's very cool that they are sustainable, and well, lovely to have you on this conference. Good luck, Victor.
Thank you. Let me first talk, maybe then you'll change your mind. So 10 years ago, I was reflecting on this a little bit. So that's Suricata 3. I don't know if anyone uses it here, but that feels like a very distant past. Lots of code changes. Also, I looked at my slides from 10 years ago, and I saw this slide where we announced our second Suricata user conference. And maybe you see where this is and what the date is, and it's kind of an important moment, and I'll get to that a little bit later. Let's just say that a day before this, there was a very controversial election in the United States, and we were there by chance, and it was a very interesting experience to be in the city there the day after. So my little agenda is, who am I? What is Suricata? Some major developments in the last 10 years, and a little bit about OISF, the organization that is behind Suricata, and then some I guess, discussion points or about the future of Suricata in a world that has changed a bit, I think. So this is me. I'm one of the founders of the organization behind Suricata. I'm the one who started the project initially almost 20 years ago when I just wanted to create a simple multi-threaded packet forwarder, and that by some luck and chance evolved into what is now Suricata. I'm online on the socials, although I'm not so active right now, but if you want to reach out, please do. So this is maybe my proudest moment, at least in work, from the last 10 years. This is the Suricata user conference in Amsterdam in the Beurs van Berlage, which of course everyone knows, and was a great conference, and just wanted to share it as one of my proudest moments. So we do a traveling conference once every year. We have a user conference always in November, and last one was in Montreal. The next one will be in Lisbon. For some reason, my team members, the Americans, always say Lisbon. I never understand where the D comes from. They don't either, by the way. I asked them. So Rogier already asked you who knows Suricata, so yes, most of them. Who already uses it now? Yeah. Who used it and gave up and this is all crap? And because you are, for me, the most interesting people. Because then I will raise my hand. Okay, I'll talk to you afterwards. We always want to learn. We are a bunch of developers. We're neither really security people or deployment people. So when we build Suricata, we really want to know from people who are actually in the field, how they use it, what problems they find, what features are missing, all that kind of stuff. So if you have things to share, especially complaints, please come talk to me afterwards, because I wanna know about it. So very quickly, Suricata is a real-time network. A security engine, traditionally mostly used as IDS, or let's say the engine in IDS. Even though IDS, the S stands for system, we consider ourselves more as a component of a larger system. So most people wouldn't use Suricata just on a command line. They would use post-processing pipelines and tooling and GUIs and all kinds of stuff. And all those things are not what we do. We just built the engine itself. Just some numbers. Things have changed. We were happy with 1 gigabit when we started, and now we're talking about 200, 400 gigabits per second kind of speeds. Although I would like have those things myself, because of course they are too expensive for me. I stole some slides from one of my team members. So why the network? Well, first of all, everything is networked these days. So almost every attack, almost every behavior has some network component. And so looking at the network is still very interesting. Also, there are many devices in networks that cannot have like endpoint devices because they are not under your control, or maybe they are too small, or they're too old, or they are brought in by your employees. So for those, it's often you have the network as sort of a source of truth, and you can see behavior. So your dishwasher, I bought a new dishwasher last year. I set up a special VLAN to because I was curious what it would do on the network. Actually, it was very uninteresting. It was very polite and not not very chatty, but it was just kind of interesting. But you can never install anything on there, of course. You're completely at the mercy of, I think it was Siemens in this case. And so we can install security products on laptops, maybe on your phone and on your servers if you want to, but there's a whole class of devices that is not, where you cannot have endpoint things. So that's where the network, I think, is still very interesting. So what is Suricata's role in this? It's a rule-based detection engine, so you can detect threats and potentially unwanted behavior. You can record entire protocol transactions, so this is what we call the NSM mode, network security monitoring, a term from our space, termed by Richard Baitlick, I think, or at least popularized, which is essentially we log all the protocol data, and then you can post-process it, and you can inspect it in your Splunk or your Elasticsearch, or you build your own pipeline. Flow logging, PCAP recording, file extraction. There are Suricata-based products, for example, that will look at your network traffic, extract files, run them through some sandbox to analyze the files for unwanted behavior. So this is a bit repetitive. So I think we use Suricata for many different things. I think increasingly we really start seeing it as a building block for larger products and services. Some examples of services and products, I think maybe last edition, was it Ott from OPNsense was here, I think, and so OPNsense is a firewall that you can deploy. It integrates Suricata. You may know pfSense. It integrates Suricata, but you may also know something like AWS, a network firewall, a service in the AWS platform, which is built on Suricata. And so there are many others, and some of them are public, and like these ones, and some of them are not so public. But so Suricata is mostly a building block in my mind. How am I doing with time? So some of the major developments of the last 10 years. So one of them is a kind of a technical one that maybe doesn't really affect users very much, but we started using Rust. So Suricata was originally built in C, is still for a large part C, but is increasingly switching to Rust. So this has been quite a journey for us because, of course, when we started the project, Rust didn't exist, and when we started using it, none of us really knew how to use it. So at one of our conferences, I think this was the Washington one, one of our community members, Pierre Chifflier, who works for the French ANSSI agency, he did a big research of what are some safer languages for building secure security tools, because security tools themselves, of course, also have lots of bugs. Well, many of you will have known problems with this in the last couple of years. So we need our security tools to be secure, and so why not use a secure language? So he presented this, not expecting us to agree with it, but we did. We actually liked his ideas, and we wanted to use it. But also, what he was doing was way too advanced for us because we were all new to Rust. So we essentially threw away everything he did and started slowly building from scratch, and actually with his support, and he helped a great deal. And so I kind of update this every year. This is a screenshot or a series of screenshots from the GitHub view of how's the code distributed. And we go from almost nothing in 2017 to close to 25% of the code base right now. And for us, this is a big deal because we actually see that in Rust, the Rust code is in general so much safer and has fewer bugs than our C code. So that's one of our big developments. So our goal is essentially every untrusted input, and we have lots of untrusted inputs like the network itself, but also the rules, and you could argue that the configuration file is also untrusted if you use services. We're working towards processing that all with Rust and focusing initially on the network traffic. Rust is not perfect. I don't know who works with Rust here, but Rust has some DevOps-y, I guess, properties, like they move fast, break things, and the Rust language is one thing, but the Rust ecosystem is another. You see lots of problems with crates that we use, so the Rust modules or libraries that support only the newest Rust compiler version, but then Debian has an old one because of course they have, and so we're going to be we're constantly sort of navigating this dependency problem. Also, crates. I think we have about 200 crates in our dependency now, and that's maybe a little bit of a risk as well. As if you build Suricata, it will just Cargo will just pull all those modules, build them locally. Some of them may not may execute build scripts and all that. So there's still work to do on trying to see how that supply chain risk can be mitigated. It's not a unique problem to us, but it is something to keep in mind. One particular weird thing about Rust is that memory allocation failures just lead to panic. And so in C, we are used to allowing malloc to be able to fail and then sort of unwind. In C, in Rust, it's just, well, I give up, I panic. And we still haven't really found a good solution for that. So, and I guess one of the problems there is that even if we do it correctly with our pure Rust code, if we use crates from the ecosystem, we also have to verify that each of them handles memory allocation problems correctly. So we'll see where that goes. One encouraging thing about that is that the Linux kernel is starting to use some Rust, and I don't think they use crates, but at least the core language is getting more attention to memory allocation failures. So we'll see where that goes. But overall, we're very happy. Once code works, it actually keeps working. We see far fewer bugs, and the bugs that we do introduce in Rust are generally logic errors and not buffer overflows and all that kind of stuff. So that's very helpful for us. Another major development, which is actually from the last 2 years, I think, is that so Suricata was usable as IDS, IPS, and so now we've introduced what we call firewall mode. So what we consider to be the difference between IPS and firewall is that essentially in IPS mode, we are completely open, and we have a rule set that looks for bad things to block those. In firewall mode, we take the opposite approach, so we have a default deny policy or default drop, and then you have to build a rule set to allow things to go through. And this allows you to build rule sets based on all the protocols, the layer 7 protocols that Suricata knows, like HTTP and TLS and QUIC and all those kind of things. And then you can build sort of firewall rule sets for those specific protocols. This is very much in development. Our latest stable release, Suricata 8, has experimental support for it. It's not very good yet, so it really happens on GitHub right now. I think the pull request that I'm mentioning here is from yesterday. So this is really very much in development, but I think this is going to be an interesting feature. Another thing, just sort of as a network processing engine, the thing that we always want to do is add more protocols, and that's this is a list. I won't go over them specifically, but we try to see as much as possible how the protocols work. One use case, for example, which came also from a government agency was, we want to look at the IKE traffic, I think, so the traffic, VPN traffic, and validate that it's securely set up. So we don't look into it, but we look, is it not using insecure settings and all that kind of stuff. So kind of validate that your VPNs are safe enough, at least on the protocol level. I guess a number of things that we do. I mentioned the file extraction from all kinds of protocols, and for TLS traffic, the GA3 and 4 support as well. So you can look at TLS traffic, and based on the GA4 hash, have some idea about what client produced that traffic, and some malware has pretty unique patterns, for example. The other thing, I mentioned the building block. So one of the things that we wanted to do for a very, very long time, essentially from the beginning, is have the Suricata functionality in a library, so in a shared library that other tools can use. And so this is finally happening. We never kind of felt ready. I always say that I think about Suricata 5, I finally thought, yeah, this is no longer what Suricata 1 should have been. But all the releases before that, I was thinking, well, this should have really been Suricata 1. But now we're at the point where we feel we can develop a proper API and all that. And actually, this was brought to us by 2 commercial vendors that already started using Suricata this way before we actually exposed it, and so we're working with them and others to make sure that this is now well supported. We also did plugins. If you know NDPI, that's one of the plugins that we currently have. But also if you have Napatech hardware, for example, and we want to move a number of the core features of Suricata out into plugins, so that, for example, Napatech is a commercial vendor that has a capture plugin, and we kind of want them to maintain that code instead of us, and so we will move it out into a plugin, things like that. Some other things, we finally started doing native DPDK support. So DPDK is a fast capture framework or network processing framework. We knew of 3 different implementations that people promised to contribute to us. None of them ever did, which is actually one of the interesting dynamics that many people don't really talk about in open source, I think, is that when someone comes to you and tells you, I have an implementation for this, I will contribute it later, you're not going to do that work because you're going to wait and think, okay, I'll let them do it. But then after some time, you're like, it's like taking kind of long. And in this case, I think we maybe waited 5 years to do DPDK because we had these promises from various people that never materialized, and finally decided to do it ourselves. So sometimes when things are not happening in open source, it's maybe because there are some promises by people that were never fulfilled. we also have Lua integration. We had this for a long time. We never did it very well. It was not sandbox, for example, and also APIs were not great. So for the last major release, we completely redid the Lua support, and so now it's properly sandbox and all those things. So what we hope is that there will be more detection scripts be shared, and that you could safely load instead of what we had before. So we'll see how that goes. That's still fairly new. I'm running a little bit behind. So I'll go quick about OISF. So OISF is the foundation that we set up to manage Suricata. So initially, when we started, by a whole lot of luck and chance, we found some US government money that wanted to seed fund us, and that that needed a US organization, essentially. So we set up the foundation. The mission of the foundation is to support Suricata development, make sure it's always open source and all those things. Initially, we had some dreams of making it bigger, like being an Apache foundation for security tools. We have talked to a number of projects that never really worked out, and I think right now we've kind of settled on the idea that we're essentially just a Suricata foundation, even though we have a different name. I'm one of the founders. Matt Jonkman, who is in this list, is still a board member with us, and you may know him as well from Emerging Threats, the rule set that many people use. He founded that as well, although he's retired from that. So the way our funding works now, because DHS funded us a little bit, well, I mean, it was quite a bit of money, but it was for just a few years, is that we have Suricata as a GPL v2 licensed tool. We own the copyrights, but we know that there are many vendors that want to integrate this or build products on top of it, and they don't always want to be restrained by the GPL's restrictions on certain areas. And so they come to us, they become a member of the foundation, of our consortium, and they pay for that. And then they get a different license, a less restrictive license to Suricata. So it's essentially a dual license model. And that has worked pretty well for us. Yeah, this is what I already said. So essentially, I think this is fairly current. We have members that are part of our consortium, and they pay our team, essentially, our development team. And I maintain a sort of a tracker of, based on the Git history of how much work the OISF team does versus contributions from others. And I think this is, well, it shows 80 to 85% or so of the development is done by the team, and so the money that comes from these companies is what funds that, essentially. And now my connection is gone. No, it's... so we use GitHub. We have our own ticket tracker, public roadmap. We have, at every Suricon, we have a public session where, with the whole audience, we sit together and talk about features and the roadmap. Yeah, we try to be as open source as possible, as public as possible, and not just dump some code on you, but actually invite people to really participate. I mentioned that leaderboard. I don't know if this is readable for you, but it's basically tracking organizations and individual members also. I think at the last Suricon, for the first time, we actually gave a special T-shirt to the top contributors, and I think that was appreciated. So did anyone here contribute to Suricata? That's too bad. I have a contributor shirt to give away, but I guess if you do a PR during the talk, we can... All right, so I think in the last 10 or so minutes, I would like to talk a little bit about a new world. And I think the word that we keep hearing everywhere today is sovereignty, right? So when we started Suricata, we had sort of a threat model to our organization and to the open source project, and it was really formed by examples from the community at the time where we had successful open source projects that suddenly just closed and they went completely closed source, or they remained open in code only, but things like issue trackers went away, contributions started no longer working, everything just disappeared into a big company, and they said, well, we'll look at it, but you really didn't see a lot of contributions go through. We saw companies get small open source companies get acquired by big ones or by very big companies. And for me, this was a very important moment, and we built Suricata and the OISF to sort of make sure that we wouldn't get acquired and that our code and our community could thrive and not sort of meet the same fate. And so I think that part actually has worked very well. We're a bit in a niche, but in our niche, we're doing very well, I think. And so we have the conference, and we have the releases and contributors and all those things. But I feel like the world has been shifting a bit, and thinking about what could be a threat to an open source project has shifted a bit as well. So especially here in Europe, I think many of us have realized that we are a bit too dependent on other countries. And that is a very, very broad topic. And so this has been on my mind for the last year or so, and I guess last 6 months even more, is sort of, what does that mean for us that we don't, that we like to have more control in Europe over our own software and all that? And what does it mean for Suricata? And maybe it doesn't mean anything for Suricata. Maybe that's the conclusion, but this is really where I'm curious about what people, how people feel about it. So sovereignty is a broad topic, of course, but it essentially means, to me, means, do you have control? Do you have access? Can you run independently from other countries or maybe big companies? And can you, well, I think for Suricata, it doesn't matter so much, but do you have access to your data and all that kind of stuff? So what does it mean for Suricata? I guess initially it's just about being able to access code and being able to also compile it, right? So Suricata has no special needs, right? So we just have the regular tool chain that's in your Debian or Ubuntu or Red Hat. You are able to modify it. There's no closed blocks of code. There's no hidden firmware. There's just the code. You can compile it. You can review it. And you can find people to do that for you. There's maybe also a difference between the organization. Like, so I work for OISF. OISF is a US-based organization. But the work on Suricata does not depend on the OISF, right? If you need, for some reason, to disconnect Suricata, the code base from that organization, you can just fork it. There's many copies of the code everywhere, not just on GitHub, also on like in your Debian source repo, you will find the code as well, and you can just use it. So we're not a gate to that. There's a public test set, for example. Our test suite is completely public. Well, 95%. There's a few bits of private data, but that's just to protect people's data, not because we on purpose have a private test set. We hate it actually to have private tests because they have to run differently and it's annoying. So I think from our perspective, lots of the technical parts of Suricata are just available enough, I hope. Then funding. Funding comes mostly from Western countries. I say mostly, but I think fully. We currently, when we started with Suricata, you would just on the internet say, "Oh, contribution, that's nice," and you wouldn't really care about whether or not a country was being seen as naughty or bad and all that kind of stuff. But nowadays we have to consider that certain countries are sanctioned, certain people may be sanctioned, or organizations. It's very hard to know. We're still finding out. I think the Linux Foundation recently had a great piece about this, how difficult it is to navigate this. So this is one of the things that we're more and more aware of, that it's a little bit less, how do you say this, innocent, I guess, the whole space. We have to be a bit more like adults. What did I want to say about that? And we know that there's lots of Suricata use we don't know about, because sometimes suddenly you hear about big implementations and people integrating it into products. Also, very often in countries where it's harder to do business, I suppose. So I think what maybe in the audience here might be helpful is thinking about where Suricata is actually developed, and our developers are mostly here in the EU. So I maintain this leaderboard. I mentioned it a few times. I think I'll share the link somewhere. Yes, right. So our current dev branch, you see some flags with some percentage. The percentage is a little bit arbitrary in the sense that we have some scoring of what the value of a contribution, and there's different ways you can look at that. But you can see there's the French flag, the Dutch flag, Canadian. Those are the first ones. Well, those are team members mostly, although we have contributors from those countries as well. And you can see that there is a long tail of many smaller contributions. And this is for the whole lifetime of the project. The Dutch one, that's mostly me. But I really like to see that there are countries and flags in there that maybe are not each other's friends, but in this little space of ours, we can still sort of collaborate a little bit. So this is one of things that I like to show. But as you can see in the bottom, almost 2/3 of the coding work is done in the EU. So is just being open source and having all the things available, like I mentioned, is that enough to support your sovereignty concerns and or is there more needed? This is one thing that's kind of a question to you, and I've asked this in other places as well. Is this enough? That's, I guess, if people have opinions, I think I'm running out of time, then I would like to hear about it. And I was going to talk a little bit about AI, but I think that's just going to skip that. So if you're interested, we have the conference in the fall. It's usually a great event, very welcoming crowd, and we're going to be in Lisbon. If you want to learn more about Suricata, we have all the usual links. And questions?
One question for myself. Can I replace my proprietary firewall in my office with your product?
I don't know your product.
Well, in the security community, they sometimes call this product that is very popular, they call it F-Grab. It starts with an F and then they call it crap. Because that product is getting hacked all the time, and it seems to be a security product. It's being sold as a very secure product with VPN and other features. But if you look to the CVE levels, it's it makes you cry. Is Suricata suitable of replacing those kind of commercial-like firewalls, or is it just too,
I would see Suricata more as a component in a product like that, and maybe a competitor could build a similar product with Suricata as one of the components, but Suricata is not a VPN.
No, I know not a VPN, but the firewall. You were
that's
saying
our goal,
about
yeah.
yeah.
Yeah. That's our
Yeah.
goal. Not necessarily going after one particular vendor, but yeah, we want this firewall component to be, I guess, world class, or how you just good enough for that kind of use. Yeah.
Okay. Any questions from the audience? If not, I can ask a few more questions. We still have some time. So, what kind of hardware do I need to run your stuff?
It depends on the speeds that you're after. So you can use a Raspberry Pi.
Yeah, but at home I have a 10 gigabit link.
Yeah.
I can upgrade to 100 gigabit at home.
Nice.
Yeah, so well, but there's not much traffic, so that's
So in general,
for that kind of speeds, like what companies have or Dutch universities. What?
in general, I think if you use Suricata on server hardware, you should think about somewhere between half a gigabit to 1 gigabit per core. And so if you're 10 gigabits, you need 10 cores. So that quickly becomes a pretty powerful machine for a home connection, right? A bit too powerful, probably. Yeah. I do question if you really need 10 gigs at home, but
Okay, and is there any possibility to do ASIC offloading for
there
like
are some
you have this
vendors.
Mellanox NICs with 100 gig, and I do know you can offload stuff. Is it also supported by Suricata?
Yes, so you can use both in DPDK. So there's different types of offloads. The simplest one is that what we call bypass. So if you know that you don't care about a certain connection, you can tell the hardware or the kernel to not show you more of that traffic. And especially if you have like backup sessions in your network that are very, very big, then you can say, well, once I recognize that, I will bypass the rest of it. And there are vendors like Napatech, for example, that I just mentioned, that can bypass that on the hardware level. So there are also vendors that do other things, I think, like pattern matching and that kind of stuff, but that's difficult to do because we do so many layers of decoding, and so you can look in a hardware offload, you can look at a single packet easily, but what if you want to look at our reassembled stream? Or what if you want to look at the HTTP dechunked bodies after decompression? That's where the hardware it's very hard for the hardware to get there, and then we would have to change the Suricata code to sort of send that data into the hardware, and we're talking about that, but not right now. Yeah.
Okay. And do you have any advice regarding, well, you already mentioned the ET Pro detection list, basically. Is there any list you would advise, or maybe not, but because I do know that some companies are selling those lists?
Yeah, so we have
so I assume that maybe for the audience it might be interesting to know that if you want to run Suricata and you want to have great alerts about malicious stuff, yeah, then the question is what to do. And I do know from history you would just start with ET Pro, I guess.
Well, you would probably start with Open because the Pro is a commercial offering.
Okay, yeah.
Open is the free subset of it. Yeah, if you're really curious about Suricata, I guess I would tell you, like, why don't you look at something like Security Onion or Clear NDR? Those are two free and open source Linux distros that have not just Suricata, but GUIs and dashboards, and just have a look at what they offer you. And then if you need more, then you can start deploying it yourself and all that. And then there are various sources of rules and IOCs. We have, in Suricata, we have something we call the Intel Index, where we list a bunch of them. But we also know that there are many organizations that have privately developed rules. We know, for example, Suricata is being used in the Dutch government, and there's Intel sharing between different parts of the Dutch government. We know that Suricata is part of NATO exercises, for example, and there's between countries sharing. And most of that is not public, not publicly available. I can tell you, for example, the Dutch police uses Suricata because they have presented about this at Suricon. But there's a lot that's not publicly available, but once you know these people, you can start sharing the rule sets and all that with each other. So there's there's a lot more than just the public side of it, which is, I guess, normal in security.
Okay, any questions from the audience? No, then I will grab your small present on behalf of the organization. Thank you very much.